Okay, so let's see what we have to configure. Like there's 16 total matches here. Okay, so we don't want to get too far along with configuring this out because we need to allow people to have the flexibility to log into the lab and take that upon themselves. So what we'll do is we'll just build a base lab, and we'll do it in 2 stages. We'll leave one open for people to be able to configure things, and then the other aspect will be a already configured lab where you can effectively validate and troubleshoot different configurations. So let's start doing that. Very small. Let me adjust this here. We can get this to look a little bit bigger so everybody can see it. A little bit better. All right, so we have 2 routers here. Let's see. So we're going to need some scenarios where we have connections and leads us into a troubleshooting. So what we can do is we can pretend that we're a business. So we're a business. We maybe have, I don't know, 3 locations. They need to talk to each other as well as sources that are on the internet. These sites need to communicate between each other, and we can bake out some interesting stuff doing that. See, is there any on here? Oh, there's no redundancy requirement. Wow, that's interesting. So I am highly surprised that there is no redundancy requirement on the local network. I guess they stripped that out of the most recent CCNA. Okay. So they took out the configuration, troubleshooting, and validation aspects of first hop redundancy protocols, and now you just have to describe it. Okay. Well, you know what? It can still. I assume you still have to troubleshoot routing, right? Interpret the routing table. Figure. Okay. This. So what we'll do is we'll make one main site, which will be the headquarters, and that'll have a little bit of redundancy in the local environment. And what we'll do is have a couple of stores that have to connect back to that main site. And then additionally, they'll have resources on the internet that they need to access as well. I think that'll be the cleanest way to do this. So we got some routers here. Grab some switches. Then what we'll do for the data center, not the data center, the headquarter location is we'll give them about 2 or 3 routers a piece and a couple of switches as well. So we'll have some spanning tree activity going on. And then these will be some spoke sites where it'll just be pretty simple, nothing crazy, just a switch and a router each. This one will be the headquarters. And these will be the individual sites. We have to zoom out on this a little bit to give us more room to operate. Headquarters here. We're going to also hook up some client PCs as well. All right. Straight through cable. Let's see what modules we have here. So typically in like a headquarters data center type of environment, you're going to want redundancy in case there is any failure. So you're going to have dual links down, sort of like this. And then these switches would also communicate with each other as well directly. Typically you'll have couple of links going between them, diversified. That way, if there's a link failure, you still have reachability. No single point of failure, if you will. So let's grab some end devices. You know, we're always going to have some workstations, right? People that are operating, doing their day-to-day business. So we'll say that in the headquarters, it's a pretty big place. Have maybe 2 or 3 people that are online. That represents the group. So this will allow us to break things and break it for certain people versus other people. Give us a little bit of nuance in the troubleshooting once we get to that point. Then we'll grab a server, and we'll put a couple of these out here as well. And this will be representative of some application that as a company they host for either internal or external communication purposes. And maybe what we'll do is we'll grab another switch. We'll throw it here. Now, typically this stuff would be like secure behind a firewall, like a server you would put behind a firewall, but with it just being a CCNA level exam, I don't want to get too deep into diversifying devices. Just routing and switching is really what we're focusing on, with some other concepts as well, like ACLs and things of that nature. Oh, we got a nice 3-stack switch here. So this will be the local headquarters. From the switch, you'll connect into your server, or whatever service it happens to be, doesn't really matter. And then from the switch down here, we'll connect our various computers. Okay. All right. So that'll be for the headquarters. That should give us plenty enough to play with in terms of setting up, some basic routing. Probably make things a little more complex than it needs to be. That way there's some configuration that you'll need to go through, and like any other production device, you're always going to have a bunch of configuration that's not necessarily relevant to what you're trying to do or what you're trying to troubleshoot. You kind of have to eliminate that fairly quickly as something that you either need to look at or don't need to look at. So it's always good to have something like that there. Not that familiar with Packet Tracer. I mainly use an emulated environment like even G. So let me see if there's some sort of text or box that I can kind of wrap this into, at least indicate whether or not this is a headquarters or not. Okay, so I can do this. Grab this. Resize this after the fact. It's going to be a pain. We'll say that this is the headquarters. Move this box. All right. Well, you know what? We'll deal with that after. Okay, so we have the headquarters pretty much mapped out. So this will be one of the branch offices. So this office will have to connect back to the headquarters for example, for things that are stored on side of the server. Maybe this is like, for example, an accounting office, right? So we're an accounting office, and we have a bunch of people that do accounting work, and I need to get back to this server because that's where we store all the customer financial data, tax returns, things of that nature. Oops, I didn't switch. What I needed was a couple of computers. So same concept here. We'll take a handful of computers, put these at a branch office, and these are fairly small branch offices, so we don't have to go crazy. We can illustrate this well enough with a single switch and a single router. We don't have to do anything crazy here. So this will be branch office A. It's all cabled up. Uplink. Okay. So now that we have that done, size this a little bit. Okay. So we have our two branch offices and we have our headquarters, so we have to get them to communicate somehow. So this is where we need to introduce a provider network, where it's typically represented as a cloud. So let's go ahead and do that. Okay, 1941, throw that here. You know, maybe what we'll say is that, well, this is an accounting office. We have the money to pay for it, so we want, you know, dedicated private lines because this has financial information. We want to be on a dedicated pathway. We don't want to send this directly over the internet, right? So we can act like this is the ISP environment. These devices together. And I need an additional line card, it looks like, for this. Off. Put 2 more gigs into it. This guy. Give us a couple of more gig interfaces. All right. So then we can this is going to make me do work. Let's look at something with a little more density than on the ISP side. 43, 31 should have enough density. What do we have? Fiber. These are Ethernet switches. These should work. For this it gives us okay. We'll do this then. Delete these. I should use these as a branch routers too. Never hurts to have more port density. This. Okay. Power it off. Put the switching modules in there. Power it on. But I'm just going to replace these ones down. A little more density. Give us more flexibility in the future if we want to do something. I am sure there is a way to clone these. I'm just not that familiar with the environment to do it. Fortunate because this is a time suck right now. All right. So let's see. We'll take this gig interface and hook it here. All right, now we'll need a crossover cable since we're going from router to router. This could actually lead to some fun OSPF or BGP troubleshooting right here. Although I don't think BGP is even on the exam, on the CCNA exam anymore. Check that. So now we'll have to figure out a addressing scheme so that we can lay out what the communication requirements are and break things. Let's see. We won't fill it with anything, but we'll draw this out. Okay, so we can say that for the headquarters, so we have the headquarters, we have site A, then we have site B, we'll call them that. But maybe what we'll do is this way. The text editor, throw it over here for now, just to make it a little bit easier. All right, so we have the headquarters, and we'll have to come up with an IP addressing scheme. So we're going to have at the headquarters a data VLAN and then a server VLAN. And we'll say that the data VLAN is 10.10. How can we do this? 10.0/24. So we'll give it that. And then this will be VLAN 10. We'll use the third octet as the indicator for the VLAN. So 10.10.20.0 will be the server VLAN. And this will be VLAN 20. For site A, we'll have the data VLAN matching up the same. And that could be, because that's all, well, so what we'll do is we'll just increment it and keep going. So 10.10.30.0. And then we'll say for site B, Copy this over. Switches out to 40. Yeah, and then if we want at the individual sites, we can add some stuff. Okay. So now that we have that fleshed out, what we'll do is for the upstream routers, we'll use different IP schemes for the peerings that need to form between them. So instead of using 10.10, we'll do 10.100. So let's see here. Off to the side. So we'll start by getting some basic IP connectivity going. Why here? Way to turn on interface labels here, that'd be nice. You have to switch between. All right, well, I guess we'll have to just go back and look at it periodically. This should have. So 0 to 1 to 0, 1. Should have made it the same throughout all the sites. Okay, so 0, 1 to 0, 1. This is going to be the only site that's problematic. Okay, so what we could do for this one, because we have effectively line cards, so we'll connect what we'll do for these ones is this is going to be router 1, so it'll be 0, 1, and then 0. Zero, 0, 1 to 0, 1. Here, okay. We'll do this. 0, 0. Which will be a little bit different. That. crossover cable. Go 0, 0, 0. 0, 1. All right, so let's start off with site B. So for site B, we have 10.10.40.0 for the data VLAN. Router. Start configuring this. So we'll update the host name to say site B. Just so that is there. Back up this. Okay. Have a reference. Okay, so we're going to go interface gig 001. IP address of 10.10.40.1 as we're going to be the gateway /24 mask. So we're going to be on VLAN 40. So this is going to be encapsulation. Okay, never mind. So interface gig 001, no IP address because this is the parent interface. So we should build out sub interfaces. And off of those sub interfaces is where you would build out all your VLANs. So this one we would say interface description. Switch 1 dash dot site B. So we would do gig 001. 40, which would be the logical identifier for VLAN 40. Let's see. IP address will be 10.10.40.1. All right, so it wants me to set the encapsulation first. Q. VLAN 40. Okay. Okay, so that's done, at least for they don't let you. Okay. All right, so that part is completed. We do need to configure a DHCP pool for the local network. So let's see, configure IP DHCP pool, site B data. Then we'll say network is 10.10.40.0. Default gateway will be 10.10.40.1. In here, you could specify a DNS server, but for now, we're not going to. It's not really necessary. Maybe when we do some like connections back to the data center, that may not be a bad thing to do. Set up like a DNS server there, or at least configure the DNS to be there, and maybe break some stuff and troubleshoot it and go from there. Okay, so we have. Okay, so this down to the switch is good. So now let's go down to the switch itself. And inside of here, we're going to have to configure the VLAN and the associated interfaces that the computers are connected to. Enable mode. Configuration mode. Set the host name to switch 1 site B. That's what we're calling it. So we'll say interface VLAN 40. Name data. Description data. Okay. So that should activate the VLAN for use. So if we do show VLAN brief, we don't have the VLAN configured yet on any of the interfaces, so we need to do that. Where are these computers connecting? Switch to, so show interface, status. All right. Fast Ethernet 1 and 0. So we could actually configure these the same. So instead of popping in and out of the interfaces, go to configuration mode, interface range, Fast Ethernet 0, 1 through 2. We can configure them both at the same time. So we say switch port mode access, switch port access VLAN 40. No shut. And then we can check for the VLAN now. So show VLAN brief. So now we see that VLAN 40 is built. VLAN 40 is active and is assigned to these two switch ports that we just configured. Now what we do need to configure the uplink, which will be this gig interface up to the router. First, let's assign. Let's see. You know what, I'm not going to worry about labeling. Typically, you wouldn't label that anyway, so we'll label the uplink. So interface gig 01. Description is try to be consistent when I name the router. Show interface description. Really? Okay. So I just put the host name in there, so that's what we'll do for the switch. So we'll say description is going to be router 1, site B. So So in this case, I'm just going to trunk the interface in case we want to add any VLANs later. Then it's already taken care of. We don't have to worry about it. So we can say switch port mode trunk, switch port encapsulation, switch port mode encapsulation. Switch port trunk encapsulation. Oh, really? So I don't have to set it to .1q. Show interface trunk. Oh, wow. Okay. So Packet Tracer natively defaults to .1q encapsulation. It used to be that these switches, because they did support ISL, which was like the Cisco version of VLAN trunking, you would actually have to set the encapsulation method before configuring a trunk. But it looks like this just defaults to it. Do they even have ISL on the... Wow, okay. Configure verify trunk ports, 2.1q native VLANs. Wow, so they got rid of ISL. That's new to me. Okay. Oh, makes life easier, so I'm not going to complain about it. Okay. So let's see. Let's take a look at one of these computers. We'll open command prompt. Ipconfig. All right. So we don't have any IP addressing yet. Let's see what's going on. For router 11, let's see. So in router 11, we configured our DHCP pool. We have that configured. We have the interface configured. Okay. Down, so that's enabled. Okay. Okay, so maybe we'll just do a release renew. Config, renew. Release. Oh. Getting my Linux and Windows commands mixed up. Okay. So there's our IP address. We can verify ping in the gateway, even though we know it's going to work because we got an IP address, right? So we should be able to do the same on this computer as well. Let's do that. And prompt, config, renew. Okay, and then we should actually be able to ping the other computer as well, which is confirmed. Okay. So this environment is ready. We have both the computers operating, we have the switch operating all the way up to the router. So at this point, we would need to configure some sort of peering with the ISP network. But before we get into that and start mixing around, switching to that type of topic, we'll go ahead and configure go ahead and configure the other sites first. Let me label router, switch 1, site B. A. Router 1, site A. Go ahead and wash, rinse, and repeat. Over so you can see it. router host name, router 1, site A. And then we'll go interface gig 001. No shut. And this was VLAN 30, I want to say. What do we have in our doc? Yep, VLAN 30 for this site. Go ahead and set that up. So this will be IP address of 10.10.30.1, 255, 0. Okay. That's good there. DHCP pool, so IP DHCP pool data. Network is 10.10.30.0. Default router is 10.10.30.1. Okay. Make sure I save the configs on the other ones too. Saved. All right. So on the switch, let's go ahead and get this configured pretty much the same way. Really anything different than what we did last time. So host name for this one is going to be switch 1 site A. And then we're going to do interface VLAN 30 to activate it. Name or description? Description, data. Okay. So interface range, fast Ethernet 01, 2. Switch port mode access. Switch port access. VLAN 30. Okay. We need to do the trunk port up to the router. So interface gig 01. Description is router 1, site A, and it's going to be switch port mode trunk. So if we take a look at these computers, should be able to do the same thing now with just doing a quick IP renew. So IP config renew. All right, what did I miss? Show interface trunk. So VLAN 30 is active. VLAN 30 is permitted on the trunk. You know what? Just some convergence there. Try one more time. There we go. Probably some spanning tree convergence. Right, Bob's your uncle. So ping 10.10.30.2 and get to the other computer. We're getting an IP, so we're getting to the router. So everything looks good there. Okay. So let's start taking a look at the uplinks to the cloud provider. So typically when you're peering with some sort of cloud provider, you're going to be using eBGP, which isn't technically on the exam, but it's not going to hurt to see the config. Let's see. Well, I could use static routes, but kind of lazy. I don't think I feel like using static routes. All right, so let's come up with an IP addressing scheme that we're going to need for the provider network. So these are all the sites. Now we're going to say ISP network. And we're going to do the 10.100 is what we said before, right? So we'll say that 2HQ will be 10.100.10.0/24. In real life, it wouldn't even be this large. It would typically be like a /30 handoff, but we'll make it work for now. We'll say to site A is 10.100.20/24. And then site B will be 10.100.30. So that'll be our handoffs in between the routers of each one of those sites. Okay. So before we get there, let's take a look at the headquarters and start getting this ready. So this is going to be a little bit different because there is multiple switches involved and multiple routers involved. But it should be fairly straightforward. Not much different than what we just dealt with. Just maybe a little bit more convergence due to spanning tree. Just drag this over here. So this is going to be host name switch 1 dot headquarters. Call this one switch 2 dot headquarters. Oops. Switch 3 dot headquarters. All right, so in this scenario, we have two uplinks that we're going to have to configure. Show interface status, do show interface status. All right, so we got the 2 gig uplinks. So that's actually very similar to what we did with the fast Ethernet interfaces down to the individual PCs at the other sites. We could just configure those within a range. So we can say interface range gig 01 through 2 and switch port mode trunk. And then what we could do is interface range We need to identify which one of these is going to the servers and which are going to the computers. So this is 5. Okay, so they're both 5. So this is actually there's no range here, so it would just be this Ethernet 5, switch port, access, switch port access, VLAN 20, because that is a server VLAN. Oh look, it creates a VLAN for me. That's nice. So show VLAN brief. VLAN is active. Show interface trunk. Trunk is active. VLANs are on it. So now we actually need to configure trunks between the other switches that we have connected. So actually, let's do this. So this is because this is an HQ. For anything that is typically static in nature and not usually moved, such as servers, you're typically going to indicate that in a switch port description. So let's do that. So for this interface, description is, say, server1.hq. .hq is server1.hq. Okay. So we know that the uplinks are the gigs and the fast Ethernet is all the other connections. We know that fast Ethernet 5 was going out to the server. So all of the other fast Ethernet interfaces will be going to the switches and need to be trunked. So that's going to be 1 through 4. So interface range, fast 0, 1 through 4. Switch port, mode trunk. Interface trunk. That's good there. We do the same thing on this guy. That. So we know that for him, he's going to be hostname of switch2.hq. Interface fast 05 is going to the server. We know that. Description server2.hq. Switch port mode access. Switch port access VLAN 20. Interface range fast 01 through 4. And this is going to be switch port mode trunk. So then we have the 2 gig interfaces. So interface range gig 01 through 2. Switch port mode trunk. Show interface trunk. So we have all 4 of our interfaces that are trunked up as we want them to. VLAN 20 has been recognized as it's in the management domain. So this one is good. And let's start taking a look at switch 3. Get this guy up and running. Figure hostname switch3.hq. Do show status. So notice here that these are already trunked, despite there not being any configuration. So if we take a look at show run interface fast01, actually it won't let us do that. So just do show run. So notice that this is, it has no configuration at all, right? 0, 1, 2, 3, 4. Nothing has been configured, yet it's already configured to be a trunk. And that is because if you take a look at the interface, so show interface fast01, switch port. Here we go. So administrative mode dynamic auto. So this Cisco switches will look for a trunking protocol to be announced. So there's like a hello that gets sent. Whenever you configure a switch port to be a trunk, it'll start sending out hello messages. And effectively what the other switches will do if it's connected on that port is if it's configured by default here as dynamic auto, when it sees that message, it'll dynamically negotiate to be a trunk port. So you really don't have to do anything. This is effectively a trunk port, but it is best practice to explicitly configure it to be a trunk port just in case something were to happen down the line. You don't want any sort of uncertainty in the environment. You want to configure it explicitly and not allow for implicit decisions to be made by the device itself. So even though this is already a trunk, all three of these are already a trunk. You can see here and negotiated. We're going to go ahead and configure them anyway. So we're going to do interface range fast01 through 4, switch port mode trunk. And then we'll see that the negotiated status went away. It's just .1Q encapsulation. We do have to configure the VLAN, so interface VLAN. There's 2 VLANs that we're going to have to do for this one because it is the switch that is connecting down to the access layer. So we'll have to configure VLAN 20 for the servers. Then interface VLAN 10 for the data. So we have these 3, which are going to be the computers. So interface range 5 through 7. Switch port mode access. Switch port access VLAN 10. Okay, so those 3 are assigned to VLAN 10. The rest of them are trunked as to be expected. This is done. So this switch is completed. Okay. And you can see here the indicators for the spanning tree, what's currently being blocked and what's not being blocked. All right. So all 3 switches are configured. Now we can move up to the routers and we can start setting out the configuration there. Go ahead and do that. Host name of router 1, headquarters. And let's see. What was our interfaces? We had 2 interfaces. We'll say that it was 001. It's going to the uplink. Show interface status. Interface description. Show IP interface brief. Pick a command. Okay. So what did I say? All right. These two are already up. So this is going down to the switches. It is really annoying that they don't allow you to show the interface description. On a real production router, you can see that. All right. Enough whining. So 011 and 012, these are going to be down to the switch. These are going to be trunked ports, but they're going to have sub interfaces. So what we're going to have to do from a high level is configure on each router some sort of first hop redundancy protocol like VRRP, and so like .1 will be the gateway, for example, then .2 will be assigned to like router 1, .3 will be assigned to router 2. They'll exchange heartbeats, so they always know who's going to be the primary forwarding router. Both of them would have DHCP pools configured. It would be the same DHCP pool, but it would point for the default gateway to the shared virtual address. Just in case one router happens to go down and there's a DHCP renewal, it would go to the router that's still up and it could still service those requests. But just in case that router is not the primary forwarding engine, then you can still have reachability through the shared virtual address. So that's what we'll have to do. Now, typically for servers, we're not going to assign an IP address. Typically that is done manually on the server itself. So usually you'll assign the IP address manually there. Yeah, so we only have to do this for the data VLAN for the computers. Okay. So configure IP DHCP pool data. Network is going to be 10.10.10.0. to 55.0. Default router is 10.10.10.1. Okay. That handles that. So 011 and 012 be gig 011.10 for the data VLAN. And why is that 011? Let's see. 011, no shot. Not create sub interface. Why can you not create a sub interface? Man, talk about no hints, huh? I don't know if I've ever run into that before. 011, 012. So it's definitely the right interfaces. have to do with the interface type. Maybe because these are switching modules. Guarantee that's it. Because they're switching modules, they don't understand. But switching modules understand .1q trunking. So you know what? Let's take this off. Rip these out. So we have 4 gig interfaces here by default. SFP or it's pretty small. That looked like an SFP. Is this an actual card? No, this is an SFP too. Okay. So you know what? We have 4 gig ports, so we're fine. We can survive off of this. This is fine. Guess I got lucky with the port assignments on the other ones. I didn't run into this. Up. Off, rip these out. All right, so we'll deal with that. It's fine. So we'll just do a single arm down. Just what it is. You know what? That's fine. Just thinking of the different failure scenarios that you would typically run into. So even if this link got cut off here, then you would just lose communication through the VLANs up here. So this would then take over as the primary forwarding router, so that's fine. Same thing in the reverse. If these links get cut here, then the traffic will just traverse down this way. And same thing, if it was taking this pathway, it would just go this way. So yeah, I think this is sufficient enough redundancy. Not even real, so I guess it's not even that big of a deal. Okay, so host name, router 1 headquarters. IP DHCP pool data. Network of 10.10.10.0. 255. All right. So what do we have here? I think it's 0, 0, 0, 0, 0. So gig 0 is what is going down to the switch. So we'll say interface gig. Description of switch 1 headquarters. No shut. So So for VLAN 10, we'll say encapsulation.1q10. IP address of 10.10.10. Actually, I have to configure VRRP. Okay, let's see. Trying to remember. It's been a while since I configured VRRP. Let's see. IP. Oh. Okay, so standby IP virtual IP address is 10.10.10.1. Yeah, I didn't. IP address is 10.10.10.2. By IP 10.10.10.1. Standby. Show standby brief. Okay. So interface gig 000 dot. What do we have for the server? 20. IP address is 10.10.20.2. Because we're going to be doing the same thing. 20. So we're going to be doing the same thing for both the VLANs, not just the one, but we're only doing the DHCP server for the data VLAN, not the server VLAN. So that's the IP address, and then standby IP is going to be 10.10.20.1. Show standby brief. So we have, okay, so we have that set up. That's good. That's good enough for now. Let's hop over to this guy and get him set up and see if we can ping across and validate HSRP is operating. So host name is router2.hq. Interface gig 00, no shut. Interface gig 000.10. And this is going to be for data VLAN. So we could say IP address is going to be 10.10.10.3. This is going to be the failover. Q10. Standby IP is 10.10.10.1. then interface gig 000.20, encapsulation.1q20, IP 10.10.20.3, standby, IP address 10.10.20.1, show standby brief. Okay. Okay, we need to create the DHCP pool. So IP DHCP pool data is going to be for network of 10.10.10.0, default gateway of 10.10.1, 10.1. Okay. Show standby brief. Show IP interface brief. Okay, so 10.10.10.2. Okay, so we don't have reachability. Let's see what's going on here. Show IP route. Okay, directly connected, so that looks right. Show VLAN brief. Yeah, so that's a problem. I never built out VLAN 10, so yeah, we're gonna need to build that out so that these switches can pass the traffic. If it can't participate in the management domain, then it's gonna be a problem. All right, so interface VLAN 10, description, data, VLAN brief, show interface trunk. Servers. Okay, I need to do node. Enable, configure, no IP domain. That should fix that problem. Interface VLAN 10. Name data. Description data. 20 description server. Brief. And this guy. IP domain name lookup. VLAN 10, description data, interface VLAN 20, description server. VLAN brief. Okay. Show MAC address table. So let's take a look at these. What's going on? All right, so our local stack is working. We just don't have reachability to the other one. So let's take a look there, see if there's anything we're missing. So this is working. So we're working on VLAN 20, it looks like. Let's see if that's true. Ping 10.10.20.3. Okay. Interesting. So we have overlapping groups, maybe? Even though they're in different VLANs? No, but that shouldn't affect IP connectivity. Show run interface 000. Interface gate 00. I do standby 1 IP. I'm gonna change the group here and see if that helps. Maybe there's just a conflict going on because of that. Oh, 10.10.10.1. No standby. Do that. Then we'll do Same thing on the other side. Maybe that helps. There really is no reason why it's working on one VLAN and not another. Standby 1 IP 10.10.10.1. Okay, so we're still not working. So what's going on here? Okay. Let's do a little bit of stare and compare. Figure out what's happening here. So we got this guy. We got this guy, right? All right, so encapsulation.1q 10.10.10.2. Subnet mask is right. Same standby group. Okay. So if we compare that against VLAN 20, 10.10.20.2, 10.3. Yeah, they're the same. I can ping across on VLAN 20. Can't ping across on VLAN 10. Okay, so let's take a look at the switches then again. So is it because I need to place an interface since I built the VLAN, but it's still not showing up in the... I have a feeling that this is a switch issue. So we got the VLAN 20 showing up. You know what I may have to do? I may have to assign a... So we need VLAN 10 to show up in here. So it'll get inside of the spanning tree domain. Let's see. So show interface trunk. So even though I created the VLAN, because it's not technically assigned to anything, it's effectively inactive, and when it's inactive, then the switch won't pass traffic on the VLAN. So I could assign it an IP address on the VLAN, and maybe that'll kind of kick it. So let's say interface VLAN 10, IP address 10.10.10.250. Maybe that'll help. Didn't. Say, what are the options? I don't think defining it as an allowed VLAN on the trunk is going to do anything. It's not shut down, so that shouldn't matter. Yeah, because we see that VLAN 10 is down despite it being built. So now the weird part is it should a logical VLAN interface should be enough to bring it up. Shouldn't have to add any routing. Just have reachability through the directly connected subnet. You gotta be kidding me. All right. Activate the VLAN. Sorry, it's been a while since I configured this from scratch. So VLAN configuration, VLAN 10. That activated it, brought it up. Jesus Christ. Okay, so we can actually say no interface VLAN 10. Interface VLAN 10. Description of data. A 10-minute head scratcher. All right, so VLAN 10, no IP address. Now this should be working. So show VLAN brief. Now it's in the forwarding domain. This should be working now. There we go. Bob's your uncle. Okay. Now if we go back to one of those computers, we should be able to renew our leases. Big new should work. Go. Notice how we got 10.10.10.4. Since 2 and 3 are assigned to the routers, we should be able to ping both of those. So 2 and 3. Okay. So this guy's good. Should be able to wash, rinse, and repeat on this. Okay, so this guy's good. And this guy's good. All right, so we are good to go. We got all 3 computers IP addressed up. We do have to take care of the servers now. They do not get an IP address through DHCP. We'll have to configure one, which is fine. So for the servers, we had, what do we allocate? 20. Okay. So 10.10.20.1 is the gateway, 2 and 3 are the router. So we'll just say 10, just to make it simple. 5.0, 10.10.20.1. Not going to worry about DNS. That's good. Okay. One. Done. Okay. We'll ping our gateway. We're able to ping router 1. We're able to ping router 2. So all that's looking good. Server is configured from that perspective. Let's take a look at this other guy. Get him all set up. So he's going to be 10.10.20.20. It's going to be 10.10.20.1. He should be good now. Ding, 10.10.20.1 is good. 2 is good. 3 is good. And I should also be able to ping the other server, which I can. Okay. That's all done. All right. So now we have all the local networks completed. Now we need to do site-to-site routing. Okay. So what did we have here? So we said that for the ISP network, this is what we drew out before. For the ISP network, we're going to be using the 10.100 space. Okay. So let's go here. Configuration mode. Host name is going to be provider. So we'll call these out based upon the primary site that they are connected to. So this will be provider B. Since this is connecting to site B. So let's see. Show CDP neighbor. CDP enable. CDP. CDP run. CDP neighbor. Let me do that real quick on all these guys. I'll save these configs as well. Just make sure that we don't lose them because we're going to be saving these labs for later. Switches should be running CDP already, but we'll configure it anyway, just to make sure. Run. All right. So what do we have? We should have the same ports except for the headquarters. So 0. Let's make this somewhat consistent, at least for those two sites. We'll do 0, 0, 1 between these. We'll do 0. 0, 1, 0. So interface 0, 0, 0. What was our addressing scheme? 10.100.30. Say .1 is on the provider side. Shut. Sky. Gig 0, 0, 0. IP address 10.100. Uh, 30.2. Shut. Neighbor. So we have provider B up. Should be able to ping across 10.100, 30.1. Don't make a liar out of me now. Come on. Okay. Subnet mismatch. Interface gig 0, 0, 0. IP address 10.100.30.1. Check your subnet mask, people. There we go. Okay. So that is operating as expected. Let's move on to the other sites. Interface gig 0, 0, 0. IP address is going to be 10.100.20.1. Shut. gig 000, IP address 10.100.20.2. Shut. Should be able to ping out, ping 10.100.20.1. Okay, so that's working. Show CDP neighbor. Okay. Now we need to get this working. 001. All right, so we identified from the ISP network to the individual locations, but now we need to do the ISP backbone IP addressing scheme. So for this, we're going to do 10.200. Actually, we don't need to. We could do 10.100.100.0. So this is for HQ to site A /24. Then when we're talking site A to site B, we do 10.100.110.0. We can make it 200, just make it simple. Okay, so for example, for the HQ, site A to site B, that would be this link here. Let's go ahead and get that configured. So that's going to be guessing 001. Is that what it was? Yeah, 001. Okay. All right. So for this guy, interface gig 001, IP address of 10.100.100.1, 255.250, no shut. Okay, so we should be able to ping 10.100. 100.1. Perfect. Okay. So let's go to here, and this link is what? Zero 1 0. Okay, so 0 IP address is going to be 10.100.200.2. One hundred 200.2. I'm gonna have to use 002. Okay. That's fine. I think we're gonna have the same problem here. These are Ethernet switching modules. All right, so what we can do then is for the, you can run fiber between the backbone. Okay, let me do that. So let's save the config. What we'll do is we'll power him down. Delete these two interfaces. Take out this hardware. Then we'll put in a and let's see what that gives us. All right, let's see. So this is here. Address is going to be 10.100.100.2. Yeah, because this is the same problem. Let me check this guy and see if I can assign IPs on all the interfaces. So inserting those SFPs trick. All right, so we're going to do the same thing to the other ones, and that's fine. So I got connectivity up to site B. Okay, so this guy's up. Good. All right. 2 to 002. 1, 001. So on the HQ, back to site A. 002, I believe. Yep. Okay. The address is going to be 10.100, 100.1. This guy, we need to do the same thing. Gig 002, 10, 100, 100.2. Shouldn't show. Right, hold on. So router 1 site A should be 10.100.20. Okay, so I messed that up, right? Yeah, because if I'm connecting out from site A to that provider A on my interface here. Yep. All right, so I just messed that up. That's fine. So provider A, base gig 000. Hold on, wait a second. So that's right. 001 is to provider B. That should be, yeah, that's the problem. Okay. Zero zero one and provider B should be 10.100.200. Check on provider B side and see if I mixed that up. So let's see, provider B, let's show IP interface brief. Show neighbor. So interface 001 is going out to provider A, and 100, 100. Okay. Go to site B. So yeah, that was the problem. I just have the wrong IP address. interface gig 001, IP address 110, 100, 200. There we go. Fix that. Show IP interface brief. Reachability then for that. So show CP neighbor 001 is going out to provider B. Yep, 002 is what should be going out to site A. So let's take a look at that. Okay, so that didn't let me turn it up because of the IP conflict, so let's do that. .100.100.1. It's working. All right. So now from HQ, we have two different links going down one router and then to another. So we're going to do on this one. 001. Okay. And 100.0.0/24. Zero dot one. Sorry. Shut. Interface gig 000. The IP address 10.100.10.1. Okay. So this guy. This is going to be 001. Yeah, 001. Be 10.100.0.2. Oh, 001, remote end 000, 100 0.2. Let's check this side. Zeros 10. Okay, so I got it mixed up. So this is supposed to be So ping 10.100.10.1. Okay. So then for this guy, one IP address of 10.100.10.2. All right, so I got that wrong clearly. Let's see what's going on. Brief. And then 7. These guys side by side and see why they don't want to talk. So I'm connecting. So this on 001 on this side, 10.100 0.1. Oh, that'd be the reason why. Oh, well, duh. Would help if I turned up the interface now, wouldn't it? All right. So now we have reachability between everything. To a certain degree. On the local network, we do. But we don't really have end-to-end reachability between all of the locations. Like this computer can't ping out to this computer. Even this router isn't able to ping out to this router. We need to have some routing protocol configured to make that happen. But I've already been streaming for 2.5 hours and I don't feel like setting that up right now. So I think what I'm going to do is step away for the night and then finish up the routing for this. And then this will be a pretty good baseline for what we were planning to do for the other videos. So injecting some scenarios where things are broken. I think this is a good baseline to start with. So I'm going to leave it here, save all the configuration, save the file, and then we'll pick it up later. So catch you guys later.